Hi, welcome to a new session of Circuits and Networks. In today's class 4, under filter design, we are going to see m-derived high-pass filter. So you can see in figure A and figure B, you have a T section m-derived high-pass filter as well as pi section m-derived high-pass filter. So how to design this filter or how to sort out this kind of filter? So m-derived filter, it is derived from a prototype of high-pass filter where you can see a T section of high-pass filter. It is shared a arm is shared by common L, that is the arms are 2C and 2C for T section, whereas for the pi section C is a center which is in the pi shape and it is shared by 2L 2L in this fashion. So this is a representation of high pass filter under K type, that is a basic type, and the important formulas related to this K type high pass filter, whether it is T section or pi section, it is given by formula 1, 2, 3 and 4, where K is known as the characteristic impedance, Fc is the cutoff frequency, and L and C can be derived from equation 1 and 2, where L is equal to K by 4 pi Fc and C is equal to 1 by 4 pi KFC. So an m-derived filter, it is the improvised version of this K-type high-pass filter, whether it is T section or pi section, it is an improvised version only. So how it is improvised, you can see the 2C and 2C, it is taken here as 2C by M and 2C by M, whereas L it is replaced by L by M. And another factor it is taken here, it is nothing but capacitor, which is a combination of 4M whole divided by 1 minus M square multiplied with this C. So this is the m-derived high-pass filter compared to K-type high-pass filter. Now input voltage and output voltage are the respective parameters which we have to measure. So an m-derived high-pass filter is the improvised version of K-type high-pass filter, which uses a scaling factor m, where the m ranges between 0 and 1. This is done to achieve a much steeper transition from the passband to a sharp point of infinite attenuation. In fact, a m-derived high-pass filter overcomes the impedance mismatch and poor stop band of prototype K-type high-pass filters. So the pi section, you can see the 2L, 2L, it is replaced by 2L by M and 2L by M like this, and C is replaced by C by M, and the improvised version of m-derived high-pass filter under pi section is nothing but it is taken inductor in parallel with this C by M, and the scaling factor it is multiplied like this, 4M whole divided by 1 minus M square whole multiplied with L. So the input and output terminals are taken, and the formulas which we need to keep in our mind apart from this K-type filter is the attenuation frequency formula, which is given by Fc by under root of 1 minus M square, and M is taken as under root of 1 minus F infinity by Fc whole square. Now this formula is quite opposite to the formula what we have seen in m-derived low-pass filter. Okay, with these formulas from 1 to 6, we can easily design an m-derived high-pass filter for T section as well as for pi section. So the first case, design a m-derived high-pass filter T section having a cutoff frequency of 10 kilohertz with design impedance or characteristic impedance of 600 ohms, and the frequency of attenuation is 8 kilohertz. So you take the given data, Fc is the cutoff frequency, or you can take the value here as 10 kilohertz, which is given in the problem. K, that is the characteristic impedance or the design impedance, it is given as 600 ohms, and the attenuation frequency is 8 kilohertz. So for the constant K type high pass filter, we know that L is equal to given by K by 4 pi Fc, and C is given by 1 by 4 K pi Fc. So substitute the values of K and Fc, we get the value of L is 4.77 millihenry, and the capacitance value is given as 13.26 nanofarad. Okay, now we are taking the formula for M in order to obtain the scaling factor. So here you can see F infinity by Fc, that is 8 by 10, gives you the value as 0.8 square. So 1 minus 0.8 square gives you the answer as 0.6. So the scaling factor value we got here as 0.6. Now for m-derived filter, the actual filter design is in this fashion for T section. You see you have 2C by M. So I'll calculate 2C by M, which is obtained to be here as 44.2 nanofarads, and L by M it is obtained to be 7.95 millihenries. and the combination of this capacitance is given by 49.7 nanofarads. Anyhow, these values are taken into the consideration and the filter is designed like this. Wherever you have 2C by M, replace it by 42.2 nanofarads. Replace this L by M with 7.95 millihenries, and the capacitance, the changed value with the scaling factor, it is replaced by 49.7 nanofarads. So this is how we design a T-section m-derived high pass filter. You try to sort out the m-derived high pass filter for pi section and comment in the chat box whether you are able to find or not. Let us go with another problem where we need to design pi section high pass filter, and the data is given as fc is equal to 2 kilohertz, k is 300 ohms, and f infinity is 1 kilohertz. Okay, we know that the formula for L and C, and it is given by 11.94 millihenries, and the C value is given by 0.13 microfarads. Now M is calculated. M is obtained to be here as 0.866. So this is a scaling factor. Now you need to remember this design of m-derived high pass filter pi section. Wherever you have C by M, calculated the value of C by M and 2L by M, the values of uh, the factors, the parameters here are obtained to be, you see, we have M is equal to 0.866. So 2L by M is 27.56 millihenry. So I'm replacing the legs with 27.56 millihenries on the either sides. Then we have C by M value as 0.15 microfarads. So it is replaced by 0.15 microfarad like this. And the combination of 4M by 1 minus M square L, which is obtained to be 165.37 millihenries, that is replaced over here. Now you have seen this. We have in the first problem we have designed T section m-derived high pass filter, and in this problem we have derived pi section m-derived high pass filter. What you do, you try to find out the T section m-derived high pass filter for problem 2 and pi section from problem 1, and comment in the chat box whether you are able to find or not. So that's all for today's class. I hope you like this session. Please share among your friends, subscribe to this channel, and subscribe bell icon for the future notifications. Thank you.